right, seniors, welcome to another beautiful day of home learning. I hope you guys are having a great day. I'd like to point out that I haven't seen very many of you in office hours or getting too many emails for questions, and that either means one of two things. One, I'm an incredible video maker and virtual teacher, or two, you guys are just lazy and don't want to ask me questions. Now, I know for a fact I'm not an incredible virtual teacher, so that leads us with one possible solution. Don't be scared to ask me for help. All right. Much love. If you guys are understanding things, that's awesome. And hopefully this isn't too bad on you. But anyway, here we go. We're going to talk today about the law of sine. So so far in this stuff we've learned about trigonometry, we've been dealing with just straight up SOH, CAH, TOA. The problem is, though, you guys, this only works in right triangles. All right, SOH, CAH, TOA is only relationships we can use in right triangles because the H means hypotenuse. So if we're dealing with a non-right triangle or an oblique triangle, there's got to be some alternative method for using trigonometry because, remember, trigonometry is a relationship between sides and angles in any triangle. We're not limited to right triangles, and that's the purpose of today's lesson. So what I'm going to do is I'm going to take this oblique triangle here, and one thing I want you to notice is that this big capital A is across from this little lowercase a. And so big A represents an angle, and little a represents the side length across from that angle, or opposite that angle. Notice big B, and then the side across from it is length is represented with little b. And then this vertex here is big capital C, and the side across from it is lowercase c. And that's true with trigonometry problems, is that you can tell which side corresponds to which angle based on if they have the same letter, just one's capital for the vertex and lowercase for the opposite side. So what we're going to do is I'm going to cut this original triangle into two right triangles. This one and this one. Call this guy on the left triangle 1, call this guy on the right triangle number 2. All right, and then I'm going to call this length here, I'm going to call it x. So here's what I know. In triangle 1, I know that the sine of angle A, this is the law of sine, so I'm going to use sine. The sine of angle A is equal to opposite, which is x, over hypotenuse, which is c. Sine is opposite over hypotenuse, so sine of A will equal opposite x over hypotenuse c. Now I'm going to do the same thing for triangle 2 over here. In triangle 2, notice here, if I want to find the sine of c, it's equal to opposite, which is x, over the hypotenuse, which is a. And you guys, I guess I should point out what I'm doing here is I'm deriving for you the law of sines. This is not something you're going to have to do on your own. I'm just trying to establish a connection between what we've been doing and what we're going to start doing. So I'm using right triangles to derive this. Again, don't stress out. You're not going to have to do this on your own. So the next thing I'm going to do is in both of these equations, you'll notice they both have an x. So what I'm going to do is I'm going to solve both equations for x. So in this one, I'm going to multiply both sides by c. And I'm going to end up with c times the sine of A is equal to x. Over here on this equation, I'm going to multiply both sides by a. Cancel out my a's over here, and I will get a times the sine of c is equal to x. Now, if both of these things equal x, well, that means they must be equal to each other. So therefore, c times the sine of A must be equal to a times the sine of c. All right? And so I've established a relationship in this triangle without using x at all. But I'm just going to tighten it up a little bit. And the way I'm going to do that is I'm going to now divide both sides of this equation by ac. And the reason I'm going to do that is on the left side, the a's will cancel, and on the right, on the right side, the a's will cancel. On the left side, the c's will cancel. So I end up with the sine of a over a has to equal the sine of c over c. Because this is the law of sines. It says that in any triangle, let's go back and look at the original triangle we had. In any triangle, the sine of some angle divided by the side across from it will always equal the sine of another angle divided by the side across from it. That's the law of sines. So in this next box here, it's in the PDF, we're going to write that. So that works for all three pairs of angles. So the sine of A over A has to equal the sine of B over B has to equal the sine of C over C. That works for every single angle and the side across from it. Every single angle, side across from it, this angle, side across from it. If you set up those fractions, you can cross multiply and solve. So we're going to do that with some examples. All right. First type of example we're going to do is we're going to solve for missing side length. All right. So to do this, first thing, in order to use law of sines, you got to know an angle and the side across from it. You got to have the angle, and we want to find the side across from it. All right. So you got to have the relationship of the angle and the side across from it. So here we go. According to the law of sines, the sine of 42 divided by the side across from it, which in this case is x, must equal the sine of 70 divided by the side across from it, which is 22. All right, so now I have a proportion, and the way we solve proportions, which you probably remember, is we use cross multiplication. So I'm going to say 22 times the sine of 42 is equal to x times the sine of 70. And again, my objective here is to get x all by itself lonesome, so I'm simply going to divide both sides by the sine of 70. Bam, bam. So I end up with x equals 22 times the sine of 42 degrees divided by the sine of 70 degrees. All right, so I need to punch that in my calculator to get my solution. So let me pull out my trusty TI-83 here. Okay, here we go. So I got 22 times the sine of 42. Oops, 42 divided by the sine of 70. Make sure you're closing your parentheses, and I get around 15.7 is what it looks like. So x is around 15.7 centimeters. It just kind of makes sure your answer makes sense. You know, remember in a triangle, the bigger sides across from the bigger angle. So if this angle 70 is bigger than this angle 42, this side should be bigger than this side. So 15.7, it makes a lot of sense. All right, so we're just going to do that exact same process again. If you want to pause here and try it on your own and then confirm your answer, that'd probably be really helpful. But here we go. So I've got this angle, 60 degrees, divided by this side. But here's the problem. Notice, in order to find x, I would need to know this angle, all right? But I don't have it, because remember, the relationship for law of sines is the angle and the side across from it. So I could find this side, because I have this angle, but that's not what I want. I want x. So one thing you got to remember is what we've already learned, and that is the triangle sum theorem. The angles in a triangle add to 180 degrees. Well, if I subtract these angles from 180, I end up with 62 degrees for that angle. So I can still do the law of sines. I just had to do a little bit of extra work in the beginning. So I've got my angle of 62 degrees and the side across from it. So here we go. The sine of 60 divided by 6.5 equals the sine of 62 divided by x. And now I will cross multiply, and I'll get x times the sine of 60. X times the sine of 60 is equal to 6.5 times the sine of 62. And then I'll simply divide both sides by the sine of 60. So x equals 6.5 times the sine of 62 degrees divided by the sine of 60 degrees. So let's just punch that in the old calculator. Here we go. X equals 6.5 times the sine of 62 degrees divided by the sine of 60. And I get around 6.6. So that makes sense. Okay, so across from 60 was 6.5. 62 degrees is a little bit bigger, so it should be slightly bigger, 6.6. All right, and the last thing we're going to do is we're going to use law of sines also to solve for missing angle measures. All right, and that's exactly what we have going on here. We're trying to solve for missing angle measures. So first, do we have the right information for law of sines? I'm trying to find this angle. I know the side across from it. I know this angle, and I know the side across from it. So I can most certainly use the law of sines. So here we go. Sine of theta divided by 13 is equal to the sine of 42 divided by 15. I will now do my cross multiplication and get 15 times the sine of theta is equal to 13 times the sine of 42. So I just cross multiplied. This stuff together equals this stuff multiplied together. All right, now I am trying to solve for theta. So whenever we're solving for an angle, that's when you use that inverse operation in your calculator. So my goal right now is I'm going to get this sine of theta part by itself. So I'm going to divide both sides by 15. And I get that the sine of theta is equal to 13 times the sine of 42 divided by 15. So in my calculator, I'm going to do the second sine option because I want the inverse sine. And inside of that, I'm simply going to put this entire fraction. So in our calculators, here we go. I've got second sine, 13 times the sine of 42. Make sure you close this parenthesis after the sine of 42, and then divided by 15. And then I'm going to close the entire parenthesis for the whole thing, and I get around 35 degrees. So theta, approximately 35 degrees. All right, and then last example. Maybe if I can scroll this guy up. There we go. All right, here we go. So in this case, I'm trying to find this angle. I know the side across from it, and I know this angle, and I know the side across from it. So I can do my law of sines. So here we go. Sine of theta divided by 15 is equal to sine of 72 divided by 15. When I cross multiply, I get 15 times the sine of theta is equal to 15 times the sine of 72. I just realized I used 15 in both problems. That's just coincidence. All right, here we go. Divide both sides by 15. Again, we're trying to get sine of theta by itself. So I get sine of theta is equal to 15 times the sine of 72 degrees divided by 15. Now, just as we did in this previous example, we're trying to solve for an angle, which means we got to use the inverse sine, or the second sine option in our calculator. So theta will equal the inverse sine of this entire fraction. So I'm going to punch that in my calculator and say second sine 15 times the sine of 72 degrees. Close that parenthesis around the 72. All right, that's how it's going in the calculator there. Sorry. Divided by 15. Close the parenthesis, and theta is 72 degrees. Now, I was hopeful that some of you in the beginning of this problem looked at this and knew right away that the answer was 72. And I did this on purpose, believe it or not, because I wanted to point something out to you. Don't forget what we've already learned. All right? In this triangle, if these two sides are both 15, then these angles must be the same because it's isosceles. And if you remembered that, you would not have had to done any work and just say, oh, theta is 72 degrees. And if I give you a problem like that on an assessment and you know right away the answer, more power to you. All right, guys, so that is the law of sines. You're just going to have a couple problems of each type, solving for sides and solving for angles in your homework, just so you can practice the concepts. All right, so thank you guys, and hope you're having a great day. And again, please don't hesitate to reach out if you need any help at all.